Hello everyone, I'm Dr. Rao. I hope you guys are doing well. Welcome to my YouTube channel Mathematics by Dr. Rao. Today I'm going to record another uh, video lecture based on the Moivre'S theorem, and I'm dealing here with some important questions. And the questions which are going to seem very difficult, but the problem, the steps whenever we are solving these are very easy, okay, and the solutions are very easy. After in some view, in some steps you can calculate these problems very easily. Okay, now start the problem, come on. So if you see, it is given. So first of all, I will solve the first part of this problem, and the problem is on your screen. Okay, so given, I will write the given one. Okay, given x plus 1 by x is equals to 2 cos theta. Okay, and y is plus 1 upon y is equals to 2 cos phi. It is given. And then prove that one of the values of means one of the values of this is this, not all the values. It means this part has more than one values. So one of the values is this, not all the values, and it is not always equals to this. Okay, remember this point. In the question it is said one of the values of this is this, one of the values. It is important. Okay, now come on. So you will see here these are two similar expressions. If you just replace x by y here, x in place of y and theta in place of y, phi, then you will get similar expressions. Okay, similar values here. So I will solve one, then similarly I will say for the other one. So come on, how can we write this? After taking the LCM, you will say, when you take the LCM here, x, and you will say x square plus 1 equals to 2 cos theta, right? So you will say x square by cross multiplying, okay, x square plus 1 is equals to 2 cos theta, 2x cos theta, right? 2x cos theta. So you can write it as x square minus 2x cos theta and then plus 1, right? Plus 1 is equals to 0. Okay, so in short, I can write it as x square and minus 2x cos theta plus cos square theta and plus sin square theta. A simple manipulation required here. In place of 1 we can write cos square theta plus sin square theta, because we have this term minus 2x cos theta, so we will try to make the perfect square of this. Okay, so you can write it as x minus cos theta whole square is equals to minus sin square theta. It is very easy to manipulate it. Okay, now taking the square root of both the side, taking the square roots of both the side, you will get x minus cos theta is equals to plus minus iota sin theta, right? Iota sin theta, because when you will take the square root of this both the side, so you will see here like this, plus minus minus sin square theta. So the square root of sin square theta is sin theta, the square root of minus 1 is iota here. Okay, so you will see the value of x here, that is cos theta plus minus iota sin theta. So there are two values of x. One is cos theta plus iota sin theta, another one is cos theta minus iota sin theta. So I will take one of the values, and similarly I will say for y, similarly with the same steps, I will say similarly the value of y will be cos phi plus minus iota sine phi. Okay, cos phi plus minus iota sine phi. Now I will say one of the values of x and y. One of the values x and y are x is equals to cos theta plus iota sine theta, and 4y cos phi plus iota sine phi. I am talking about one of the value, okay, because there are another two values, okay. So I am talking about one of the values for this, okay. So come on, what about the x to the power n? Now I need to solve the part number 1. X to the power m, x to the power m plus y to the power n plus y to the power n upon x to the power m. So I will say I need to prove x to the power m upon y to the power n plus y to the power n upon x to the power m. So come on, what about this? The value of x is cos, or in short I will say, I will say cis theta, and it is your cis phi, right? Cis phi, okay, cis theta and cis phi. So come on, in place of x I say cis theta to the whole power m and divided by cis phi to the power n and plus cis the phi to the whole power m and divided by cis theta to the whole power m, and see it is n, okay. So by the de Moivre's theorem, you can say by de Moivre's theorem, we can say it is equals to cis m theta and cis n phi plus cis n phi and cis m theta, right? M theta. So in short, on simplification you can say cis m theta minus n phi, right, and plus cis n phi minus m theta, okay. Now come on, what we need to prove here? Let me check it out, okay. 2 cos m theta minus n phi, 2 cos m theta minus n phi. So if I write this cos m theta minus n phi, then plus iota sine m theta minus n phi, right? And similarly I will say here plus cos n phi minus m theta and then plus iota sine n phi minus m theta, right? So I can take minus outside because see the angles, there is a difference in the minus difference in both the angles, okay. So cos m theta minus n phi, right, and plus iota sine m theta minus n phi, right, and you see here cos, you can write here cos m theta minus n phi, right, because cos minus theta is again cos theta, okay, plus iota, but cosine minus theta is equals to minus sine theta. So you will write minus iota sine m theta minus n phi, right, for this, okay, for this. So you will see these are the same terms, these are cancelled out. So what is balance, or balance number of terms? So it is 2 cos m theta minus n phi, which is to prove, okay, which is to prove. So is 2 cos m theta minus n phi. So one of the values of this, okay, because you are taking the one of the values of x and y these, so the one of the values is this. Very good. Now come on, what about the second part of that? Okay, similarly you will follow up the second part of that. So how will you solve the second part? And the second part is this. Now you are having the value of x is as cis theta to the whole power m and cis phi to the whole power n, and then plus 1 upon cis theta to the whole power m and cis phi to the whole power. These are very basic questions. What about these values? X to the power, okay. Now we are starting the solution here for the part number 2, okay, and we have written these values for x to the power m, y to the power n, and plus 1 upon x to the power m and y to the power n is equals to this, okay. Now come on, so we can write by apply the de Moivre's theorem, right? Apply the de Moivre's theorem here, de Moivre's theorem, okay, apply de Moivre's theorem here. So you can write here cis m theta, right, and cis n phi, and then plus 1 upon cis m theta and then cis n phi, okay. So what about this? It is cis m theta plus n phi, okay, and then plus 1 upon cis m theta plus n phi. Very easy, okay. Now what about the resultant? So you can write it here cis, you can say it cis m theta plus n phi, okay, and then plus you can write here cis m theta plus n phi, right, power minus 1, and you can again apply here the de Moivre's theorem. So you can say it is this and cis minus m theta plus n phi, okay. So now expand in terms of cos and sine. You will write cos m theta plus n phi, okay, plus iota sine m theta plus n phi. Steps are very simple, okay. Similarly for cos minus m theta plus n phi, and then plus iota sine minus m theta plus n phi, okay. Again apply the property. So you will see cos minus theta is again cos theta, so you can say it is 2 times of cos m theta plus n phi, okay, and sine minus theta is minus sine theta, so you will see these terms will be cancelled out. So it is your final answer, I think, which is proved, okay. It was to prove 2 cos m theta plus n phi. It is the one of the values, okay, hence proved. So I hope guys you have enjoyed these 2 questions. So we will meet in the next questions which are going to important, okay. So thank you very much for seeing the videos. So we will meet in the next video lecture.